Hello students, welcome to the topic analysis of univariate data. This is the first lecture and a very interesting topic where you will be having lots of new formulas and lots of new things to learn and understand. So, we will see what is univariate data. Uni means one. Data with regard to a single variable is called univariate data. Generally, frequency distribution are characterized by the following measures. Measures of central tendency, or also known as measure of averages, measures of dispersion or variation, measures of skewness, that is asymmetric, measures of kurtosis, that is peakedness. So in this particular chapter, that is analysis of univariate data, these are the things you will be learning. First, we will be dealing with measures of central tendency. What is central tendency? What is dispersion? What is skewness? What is kurtosis? All this we will be doing one by one, step by step. Today we will be dealing with measures of central tendency. What is this measures of central tendency? In the previous chapters, data collection and presentation of data were discussed. Even after this, one may often find the data complex either to remember or when a comparison between any two series is necessary. Thus, in order to reduce the complexity of data and also make them comparable, it is essential that the data be reduced to one single figure. For example, if the comparison has to be made between marks in a subject obtained by a group of 100 students belonging to one college and the marks obtained by another group of 80 students of another college, it is not possible to arrive at any conclusion. On the other hand, if each of the series of marks is represented by one figure, comparison would become easy. This single figure so obtained is known as an average. That is, an average is one which represents the entire data, lies between two extreme observations of the data, and it also gives an idea about the concentration of values around a central value. Hence, they are also known as measures of central tendency. So, this is the what I call it as a description part. Now, we will see what the objectives of averaging, why we want averaging or why we have to study central tendency. First point, to get a single value to represent the characteristics of the entire mass of the data, to facilitate comparison or to help to compare. Now, for example, the best example what I can give you all for central tendency is your 10th marks card, your PUC 1 marks card. You never, if someone asks you what you have scored in 10th or if someone asks you what you have scored in 9th, you don't tell to everybody English I got so much, maths I got so much, Hindi I got so much. No, you don't say that. You just give one value, that is you just tell your percentage. What is your, it's nothing but central tendency. You're representing your whole subjects into one value, that is your percentage, that is the meaning of central tendency, where all the huge data is represented by one single value. We will see the definition. Central tendency, it is the property of concentration of the values around a central value in a data. Yes, as I told you or I gave an example, whenever the marks are there of your 10th standard, you tell I have scored 85%, I have scored 55%. We never say that the maths, science separately, it's never that. You never give it. All the 6 subjects are represented by one value. That is central tendency. Measures of central tendency. Average. It is a single value that represents the entire mass of the data. Now this is important in the sense for 1 or 2 marks. Essentials of a good average. First point, it should be easy to understand and simple to calculate. Second one, it should be based on all the observations. It should be well defined by a mathematical formula. Fourth, it should not be affected by abnormal extreme values. It should be capable of further algebraic treatment. It should possess sampling stability. It should be easily calculated for an open-end distribution. So these are the requirements or for a good average, essentials of a good average. So the one who satisfies the maximum points, he is the best formula, we can say. Now, what are the things you are going to study for the PUC 1? types of averages. How many averages or how many formulas you're going to study? First you're going to study arithmetic mean, then you have median, then you have mode, geometric mean and harmonic mean. So total 5 averages or 5 formulas or 5 different means will be types of averages will be studying. So we will be dealing today with the first one, that is arithmetic mean. What is arithmetic mean? What is the definition? What are the formulas you have to remember? The first one is arithmetic mean. The most popular and widely used measure for representing data by one value is what layman call average, and the statistician call it as arithmetic mean. And what you have to remember or types of arithmetic mean is simple arithmetic mean and weighted arithmetic mean. Weighted arithmetic mean is only for the knowledge purpose. What you are going to mainly deal is with simple arithmetic mean. So what is the simple arithmetic mean? Simple arithmetic mean, which is calculated for a data giving equal importance to all the items in the data, is called simple arithmetic mean or simply mean. We will see the right or the correct definition. How do we define arithmetic mean? Arithmetic mean of a set of observations is their sum divided by the total number of observations, and it is denoted by x bar. Remember, every type of average or average is got some notation. Mean we denote it by x bar, median by m, mode by z, harmonic mean by hm, geometric mean by gm. So what is this formula here? X bar is equal to sum of the observations divided by the total number of observation. You have done this so many times, but you don't remember that exactly you have done this arithmetic mean only. It's very simple and very easy to understand. We will see the formulas. Now see, one more thing I want to make it very clear to you all. Now as you're studying statistics for PUC 1, you're going to study everything step by step, everything in detail you're going to study. You will be having a formula for ungrouped data separately. You will be having a formula for grouped data. So you have to bifurcate. Raw data, the formula is different. Then classified tabulated data, the formula is different. Ungrouped means individual raw data. And grouped means it is organized, it is well tabulated, it is having a class interval, it is having frequency. That is known as grouped or classified or tabulated data. So the first is calculation of arithmetic mean. The first type of formula is for ungrouped data or individual observations. There are also different formulas. You are free to use any formula of your choice, but we are mentioning what are the different formulas you can use. This is the first one, is the direct method. If x1, x2, so on, xn are n observations in our data, then x bar is equal to x1 plus x2 plus so on till xn divided by n. This we sum up. This is known as summation and not sigma. Summation x divided by n. This is the formula. Next, the same for ungrouped data, you have the deviation method, or it's also called as the shortcut method. When observations in a data are large in magnitude, then this method simplifies the calculation. What's that formula? X bar is equal to a plus summation u divided by n, where a is the assumed mean, u is deviations of observations, and a is equal to x minus a. Sorry, this is u is equal to x minus a. I'm so sorry. This u is equal to x minus a. So they have proved and they have come to the final conclusion what it means. So here u is equal to x minus a. This is simple summation u they have taken for all of them. It's just for the knowledge purpose. The only thing what you have to remember is u is equal to x minus a. X are the values and a is the assumed mean. So remember u is equal to x minus a. And the formula for arithmetic mean for deviation method is this. Next, we will see for grouped data. For grouped data, what is the formula? As I told you all, grouped data, discrete data and continuous data. Again, discrete means you only have x and f values. Continuous means you will be having the class intervals. The direct method, if the observations x1, x2, so on, xn have corresponding frequencies f1, f2, so on, fn, then x bar is equal to f1, x1 plus f2, x2 plus so on till fn xn divided by f1 f2 plus so on fn. This is summation fx divided by summation f. Summation total frequency is always denoted by capital N. So for discrete data, x bar is equal to summation fx upon n. For continuous data also the formula will remain same. Again, a deviation method is nothing but the shortcut method. Shortcut method you have to remember, x bar is equal to a plus summation fu divided by capital N, where u is equal to x minus a. Same thing, x are the observed values and a is the assumed values. This they have derived, it's fine, you have to just go through it, not important. So this is discrete data, two methods, direct method and deviation method, you have to remember. And in statistics we never put the condition that you have to use this method, that formula. No, you have the freedom to use any formula of your choice, whichever you are comfortable with. Next, for the continuous data, the process of calculation is same as in discrete series, except that in continuous series the values of x are the midpoints of the corresponding class intervals. Now if you observe, for continuous and discrete the direct method is same, that is x bar is equal to summation fx divided by n. But for step deviation, now what is continuous data? Continuous data means nothing, it is in class interval and f, 0 to 5, 5 to 10. When such class intervals and frequencies are given, now this is known as continuous. And what is discrete? Discrete means x and f value. Straight away 2, 4, 6, all the x values will be given and different f values will be given to you all. So that is known as discrete. Discrete will not be having class interval. Continuous will be having class interval. That's all you have to remember. Because you are having a class interval, the formula will change by only one step. And this is known as step deviation method. And what is the formula you have to remember? X bar is equal to a plus summation fu dash divided by n into c. Now why this c is come? Because you are having the class intervals, that is nothing but the width. So here u dash is equal to x minus a divided by c. X are all the different values of x or the midpoints, a is the assumed mean and c is the width of the class interval. Yes, so this is what you have to remember for continuous data. Now this cumulative series. Cumulative series can either be more than or less than. In the former, the frequencies are cumulated upwards so that the first class interval has the highest cumulative frequency. In the latter, the frequencies are cumulated downwards so that the last class interval has the highest cumulative frequency. In both the types, initially the data are to be converted into simple series. Afterward, the calculation of mean is done, as in the case of continuous data. Suppose if in case the cumulative values are given to you all, you are going to remove first the frequencies and then find the arithmetic mean. So this is only for the knowledge purpose. Don't confuse yourself with the cumulative series. That's fine. The next important part is the properties of arithmetic mean. Yes, very important. They have asked for 1 mark or 2 mark. Mean has got certain properties, very important. The first one, the algebraic sum of deviations of a given set of observations taken from their mean is 0. This is the property. Summation x minus x bar is always equal to 0. Means when you subtract the values from x from arithmetic mean, and when you total it, its value will always be equal to 0. Second, minimal property of mean. The sum of squares of deviations from their arithmetic mean is least. That is, summation x minus x bar to the power of 2 or to the square is the least. Means this table value, when you apply, its value will be always less, very little it will be. And third, the third property you will be using the formula combined arithmetic mean. If we know the sizes and the means of two series, then the mean of the combined series can be obtained. X bar C is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2, where xc bar is the combined mean and n1 and n2 are the number of observations of the first and second series respectively, and x1 bar and x2 bar are the means of the first and second series respectively. Now what is the meaning of this combined arithmetic mean? Combined arithmetic means, for example, if you want to calculate the arithmetic mean of your PUC 1A class and you want to calculate the arithmetic mean of PUC 1B class, together you can calculate its arithmetic mean by using this formula. That is the meaning of combined arithmetic mean. 2 or more also you can calculate. So the properties are really important. Now next comes the merits and demerits. Everywhere you have the merits and demerits, and they are simple and easy also to remember. The first one, it is easy to, what are the merits of arithmetic mean and what are the demerits of arithmetic mean? That's what I'm trying to tell you all. First point, it is easy to understand and simple to compute or to calculate. Second, it is based on all the values. Third, it is well defined by a mathematical formula. It is capable of further mathematical treatment. Then it possesses sampling stability. So these are all the plus points of arithmetic mean. Now we will see what are the negative points or what are the disadvantages, what are the demerits. First one, it is highly affected by abnormal extreme values. Means if you have scored, for example, what the best example, you have scored 95 in maths and then you have scored just 40 in Kannada. 95 also is extreme highest value and 40 is extreme lowest value. So here the percentage will hamper. So that is the meaning of abnormal extreme values. Second one is, if the distribution have open end classes, then it cannot be easily calculated. Open end class interval means more than 5 or less than 5. When you don't have the one of the lower limit or one of the upper limit is missing, that is known as an open end class. Then it cannot be used for qualitative data. Means quality you cannot apply arithmetic mean. Then it cannot be obtained graphically. You cannot get the value of mean by graphs. You can get the value of median from ogives and you can get the value of mode from histogram. So through graph mode can be obtained, through graph median can be obtained, but arithmetic mean cannot be obtained graphically. Qualitative data means attributes, that which you cannot measure, you only have to feel it, intelligence, beauty, peace, goodness, badness, that is all you only have to feel and see it. The ones which you cannot measure is known as qualitative data. So these are the merits and demerits of arithmetic mean. So children, what you have to remember in today's class is simple. You remember the definition of central tendency, essentials of a good average, then what is the definition of arithmetic mean, the different formulas, that is for ungrouped data, which are the formulas you have to remember, for grouped data, what are the things you have to remember, under grouped, discrete, there is a different formula, continuous data, there is a different formula. So remember those formulas, very very important. Then comes the merits and demerits. So this is what you have to keep in your mind for arithmetic mean. Remember the formula, based on the formulas only we will be solving the examples. So for today's class it's done. We will see more in the next lecture. Thank you.